Hey everybody, welcome to Lab 5 for Physics 1106. Okay, so this lab is all about buoyancy. And before we start, let me just show you what you're going to need for the lab. You're going to need your spring scale, which may or may not even be in a baggie or a box. And you're going to need your blocks that you might have. Sorry, I know that this virtual background is really hard to work around. Here we go. Okay, let's see, put it from my face. There we go. One of your blocks, the block you also, it might look like this. Some of you also, I would recommend you can even use your mass set. So you can see, remember the mass sets that you have these little slotted weights. You can use a couple of these for some of your calculations. Okay, so let's take a look at the manual. All right, so what we're after in this lab is the density of these blocks. Okay, so how are we going to do that? So what you're going to need is you're going to need a glass of water. I would use a clear glass so you can make sure that your object is submerged completely. I mean, maybe you can see that in a cup, but I like to use a clear glass. You're going to make sure that your object that you're putting in there is completely submerged. Okay, so the object that we're going to be putting in there is one of these blocks, right? Or a couple of the mass sets, the masses from your mass set, etc. And we're going to be figuring out how much that object weighs in water when it's completely submerged and out of water by hanging them from the scale, right? Okay. So you're going to need some string to tie around these objects. It's kind of a pain, especially to tie around a block like this. All right. Anyway, so what you're going to do is weigh it in water and out of the water. And you can see here that once you submerge your object, there's going to be a buoyancy force, right? That's like when you get in the pool, how you feel a lot lighter because there is a force pushing up on you when you're in the pool. And we know that buoyancy force, the magnitude of that force is equal to the weight of the water that you displace in the pool. So the same thing for the object. It's that force is equal to the weight of the water displaced by the object. Okay, so there's a bunch of equations here about how this works. So for instance, when you're weighing your object in water, right, that weight is going to be given by the tension in the string. So what you read off the spring scale when it's submerged, and then plus the buoyancy force, right? And that has to match the weight that you got when you weighed it outside of water. Okay, but we're after the density. So I want you to you're just going to scroll down. Okay, so there's a couple equations before this, but you can see that the buoyancy is the weight of the water displaced, which would be the density of water, which is given right here, times the volume of the object, right? Because that gives you the mass of the water, right? Times G, right? So it's the mass of the water displaced by the object times G, okay? And as you know, density is just mass over volume. So that's how we got this. The density of the object is what we're after, okay? So if we scroll way down here, okay, there is an equation that uses all the things that you have. Okay, so for instance, the density of the object is going to be given by the density of water times the mg of the object, right, the weight of the object, over the buoyancy force that you measure. Okay, so we're after this density. Why? Because we want to see what is the object made of. All right, so you probably will notice that when you hold your objects that they're slightly different weights, right? One of them may be much heavier. And certainly for me right now, I have this object, which I know is aluminum because it's super light, compared to these guys, which is probably brass just from the color, but I'm not really sure. Okay, so, but they're much heavier than the aluminum. But we want to verify this. And also, right, I know one of my objects is going to be aluminum. Maybe both of the objects that you get are aluminum, right? Your job is to figure that out, right? So if both of your objects feel pretty light, they're probably both aluminum, but you want to verify this in your experiment with errors and compare it to the known density of aluminum, which you can look up, okay? Also, when you use your mass set as a different metal, you want to see, does it match? Is it actually brass? I don't know, maybe, right? You're going to get the density of this object. And here, what I would do is put a couple of them together, right? And then use them as like a little pack, right? And then you're going to see, does that match the density of brass? Or maybe it's something else. I actually have no idea what they're made of. I'm just guessing. And make sure it's completely submerged. So don't use the mass hanger to do this, because you'd have to submerge the entire thing, right? So I would probably not use that. I would tie your string around a couple of these together and then do it. Okay, so that's your job. And you're going to do that, of course, with error analysis, right? Figuring out how much error is, because you had to measure the weight of the object. You have to measure the buoyancy force, right? So I would look through this. There's a little calculation of how to do all that. Okay. All right. So remember, your goal here is to get the density of these objects and compare them with accepted values. And even if you, when you get the density of, say, an unknown, right? Say this one is one that you don't know, because some of you may have a much heavier object, and you don't know what it's made of. You don't know what it is. So yes, there's no accepted value for that one. You're just going to go on the web and say, okay, this is closest to steel, all right? Or this is closest to brass, or this is closest to whatever else, nickel, or whatever else you find your density close to. Be careful of your units, right? And you've got to look up the densities in the correct units, right, that you have, so you can compare. Okay, well, I hope you have fun with this one, and I'm looking forward to seeing your reports.